let's get into reviewing probability. We learned back in Unit 9 that there's two types of probabilities. The experimental, which is going to be us doing an experiment and then finding out the results. So experimental is going to be the probability of what actually happens. We're not assuming, we actually have evidence of what happened. So for example, it can be we made a survey, we get a table of results from a spinner, or any tables with informations, tables of recordings of an experiment. So for example, when you throw the dice, how many times you got heads and how many times you got tails. Okay, so that's the experimental. When the event already happened several times and we recorded the results, we get the probability from that. But theoretical is gonna be what should happen. And I'll give you an example. When we toss a coin, there are only two options. The probability of tossing a coin should be 1/2. Either we get heads or we get tails. The probability of having a spinner with four numbers is gonna be 1/4 because we're gonna get one number out of the four we have. That's what should happen. But sometimes that's just a theory. Sometimes the results are different. So we're gonna put here, that's the difference. And you're gonna have multiple problems in your student practice about this. Let's read the problem now. And make sure you're underlining what the question is asking us. John has a spinner divided into 7 equal sections and numbered 1 through 7. We don't have to, but we can make a little image here. 1, 2, 3, 4, 5, 6, 7. So we're gonna pretend that this is equally divided. And then each time he spun his spinner, the number of spinner landed on was recorded. So that's what I'm talking about. We already have results here. This is telling me that we landed on number 1 5 times. We landed on number 2 1 time, so on and so forth. Now the question is, based on these results, underline, what is the experimental probability that the next time John spins the spinner, it will land on 4 or 7? So this is important. I'm gonna underline and mark this. 4 or 7. We've had multiple problems like this. And remember, this is a very important keyword. Or is gonna mean we need to add both of these. The frequency for 4, for the number 4, and the frequency for number 7, which was 6. Okay? And then for both of these, even if they're different, they are both gonna be found by doing the part over total. Okay, so that's what we need to do. So what is the probability that we land on 4 or 7? So the part in this case is gonna be the frequencies we got those numbers. So for 4 it was 3, and for 7 it was 6, so we're gonna add them. And now the total number of spins is not given on my problem, but I can find it by adding all the frequencies. So this is how I'm gonna find my total. So 5 plus 1 is 6, plus 5 is 11, plus 3, 14, plus 6, 20, plus 7, 27, and plus 6, 33. And that is my total. Okay, so now I simplify this. 3 plus 6 is 9 over 33. However, none of this is in my options. That means I need to simplify. Let's look for the common denominator for 9 and 33. If you look at your denominators, we cannot divide 9 by 2, so this is not an option. If we're simplifying the denominator, something should also be happening to our numerator. So that means D is not going to be my option. So it's either A or B. And then let's try dividing by 3. 9 divided by 3 and 33 divided by 3. This is going to be 3 over 11. And then just as a side note, if you don't know how I got 11, 33 divided by 3, it's 11 times. So then my answer is going to be 3 over 11. That was a long video, sorry.